All right, here we go. Let's continue with more circles. All kinds of stuff to learn about circles. Seems like such a simple little thing, doesn't it? A circle. Like, how in the world could there be so much to know about circles? Well, there is. All right, so let's start drawing a circle. Let's move that up a little bit. Let's put the center. I should have a circle that's already drawn with a center. I wonder if I have that. Did I put that? Got all these shapes. Oh, there's circles up there. Well, I'll just use this one. But I can copy and paste it. All right, here we go. We are going to talk about a few things. Let me draw a couple things in here first. All right, I'm going to draw that. What is that thing right there I just drew? Oops. What's that thing I just drew? It goes from, a diameter. It goes from one end of the circle to the other. It goes through the center. That's a diameter. And what's that thing right there? That's a radius. I have a couple other radii as well, don't I? If I got that diameter, I got two radii, one going this way, one going this way. All right, so those are all the same. But right now, we are going to talk about something else. I'm going to make that angle 60 degrees. Yeah. And let's put some letters in here. So I'm going to call this W and X. Call this V in the middle. Call this Y right here. And we're going to just pick some random point over here, and I'm going to call it Z. I'll show you why in a minute. All right, I think that's everything we need. All right, so we got a couple words we're going to talk about. Then we'll say something and use some numbers and all that kind of good stuff. All right, so the first thing, what was the title of this lesson, by the way? Arc measure, right? So we're going to talk about an arc. So let's do that. Change different color. Make it a little thicker. All right. Watch. I'm going to go around the circle, okay? It's not just a straight line from W to X, but I'm going to actually go on the circle itself from W to X. Everybody see that? So from there to there. We give that a name, and we call that an arc. Good. All right, so that's an arc. There's ways that we can designate that it's an arc, all right? We have like little symbols for it. You know how you had a symbol for a line segment? You had a symbol for an angle, right? You had a symbol for a line, a ray. We got symbols for all kinds of stuff, right? So we don't have to write the word down every single time. Same thing with an arc, right? So here's what we're going to do. Do you see how the arc is between W and X? Everybody see that? So what do you think we're going to call that arc? Very good. Arc WX. So you put a WX. We've got a little symbol for an arc. And it kind of looks like, guess what? An arc. All right, so there you go. You put that little half moon looking thing over top of it. Kind of almost like a half circle. Not quite half circle, but it's a little arc to it, okay? So that's called an arc. So instead of writing the word arc, if you put a WX with that little curvy thing on top of it, that means it's an arc. It goes from WX, or it could go from where? From X to W. That would be the same exact arc. Wouldn't be any different. Just like line segment AB is the same thing as line segment BA. Line AB is the same thing as line BA. Everybody with me? All right, so that's what we have right there. So that's pretty good. Here's something that's kind of interesting. How do we measure an arc? Well, let me ask you this. What if I started at W and I went all the way around and I ended up at W? What do I say that? What do I say about that? Say it again. 360 what? Degrees, right. It's 360 degrees. So that would be an arc. If I start here and I went all the way around the circle, that would be considered to be an arc. All right. It's just a 360 degree arc. How many degrees do you think this arc is right there? It's 60 degrees, exactly right. So you look right here. Do you remember what that word is for this angle it's in? I don't know. Maybe I haven't talked about that. Yeah, I don't think I have. Okay, we call this a central angle. I thought we did. We call it a central angle. Why? Because the vertex of that angle is where? At the center. Exactly right. Oh my word. I'm getting all these texts. Hold on, let me just see this. Ugh. Short video for a senior commitment. All right, hold on. All right. They're asking me to do a video. I said I don't do videos anymore, but I guess I'm going to do this one. All right. Where was I? Arc central angle. Okay, so check this out. This arc is cut off by this angle. Everybody see that? And it's a central angle. Okay, this only works when this is a central angle. All right, so if the angle has a vertex at the center, then this angle is going to equal this arc. So if this angle is 60 degrees, what is that arc? That's also 60 degrees. You with me on that? So they're exactly the same. But it has to be the central angle. It can't like start from here and go to there and go to there. Everybody see that? It has to be from the center. All right, we are going to talk about some arcs that actually start on the circle and go to W and go to X. But that's not today. All right, I think it's tomorrow actually. All right, so this is a central angle. This is the arc. We say that this angle cuts off the arc. Does it make sense? So here's the angle. It goes to here. Boom, cuts off right there. This goes to here, cuts off right there. So this is the arc that's cut off by that angle. And that would be 60 degrees. You good? It's also less than 180, isn't it? 60 is less than 180. So anytime we have an angle, anytime we have an arc that is less than 180 degrees, we give it a special name. Less than 180 degrees. We call this a minor arc. And we're going to refer to these words from time to time, okay? And it's important that you know what I'm talking about. So if I say this is a minor arc, you know that that arc is less than 180 degrees. All right, let's do a different color. What if you had an arc that was exactly 180 degrees? So give me an arc that's exactly 180 degrees. From W, where do you think? Or I'm sorry, from W. I'm starting from Y, sorry. Or you can start from W, it doesn't make any difference. If I start from Y, if I go all the way around to W, boom, right there. I didn't just pick two random points on the circle. I picked 2 points specifically. Why did I pick those 2 points, do you think? Because this would be the arc, or this would be the central angle, wouldn't it? What is that central angle right there, that yellow angle? It's 180 degrees, right? So what do you think this arc is right here, this big old fat yellow arc? It's also 180 degrees. Does that make sense? All right? You guys know about, right, 360s all the way around the circle. Halfway around the circle would be what? 180 degrees, right? Yes? All right, so that arc would be 180 degrees. So we say an arc that's equal to 180 degrees is called a semicircle.
Are y'all ready to the office for the circle, please?
Okay, so I'll just put equals. Okay, it's a semicircle. So 180 degrees exactly, right? If it equals, tell you what, let's do this. Let's write the word equals instead of an equal sign. So if it equals, these are all arcs, okay? Arcs that are less than 180, arcs that are equal to 180. So what else do I have? I could have an arc that's what? that's greater than 180. I bet you could probably figure out what the name of it is. So if it's less than 180, it's a minor arc. What do you think it is if it's greater than 180? It's a major arc. That makes sense, doesn't it? Yeah. Let's raise that up a little bit. And let's find an angle, or an arc, sorry, that's greater than 180. So, I don't know. Let's start from here. Let's start from X. And from where? W to Z? All right, let's do that. Let's go from W to Z. So here's W, but which way am I going to go? Am I going to go this way? Okay, I want a major arc. So W to Z, I wouldn't go to there, would I? Actually, I changed my mind. Let's go from Y to X. I'll show you why in a second. So I'm trying to go around the yellow so I don't cover it up. So Y to X, all the way to there. Anyway, I'm trying to go along the circle. I missed it a little bit, but you get the idea. Now, you know that's more than 180 degrees. Why? Because I went from here and I went past where that diameter hit, correct? And I went a little bit further. So you know it's more than 180 degrees. So that would be a what? A major arc. You got it? On a minor arc, you just use 2 letters, like we did right there. For a semicircle, we actually use 3 letters. So let me just write this over here. So for that yellow one right there, that's why I didn't want to cover it up so we still see it. If I wanted to name that yellow arc, that yellow semicircle, all right, what I'm going to do is I'm going to put the start and the end, right, at the end of my 3 letters. But then I got to put the letter that's in between. So it just seems like I'm saying the same thing. So watch. This goes from Y, the yellow one. That's why I'm drawing in yellow here. If I go from Y to W, you got to have a Y and a W. But how do I know if I'm talking about this semicircle or if I'm talking about this semicircle? I don't know, do I? All right, so what do you need? You need another point in between so you know which semicircle you're talking about. Does that make any sense? All right, so I can't just say arc YW because some people would think it was this one. Some people would think it's this one. So how do we all stay on the same page? You got to have a letter in between. So what would I put in between here if I'm talking about the yellow one? Yeah, I put a Z in there. And you put a little arc symbol over top of it. So this is the yellow one. See it? Any questions? What about the pink one? The major arc. So where'd you start? Started at Y. Did I have that as a letter? What was that? X? Let me just put it. Yeah, kind of cover it up. There. Okay, that point right there was X. All right, let's go back to pink. Okay, let's do the pink one. So if I started at Y, I actually go through 2 different points, don't I? If I'm going to go from Y to X, I got to go Y, I hit Z, I also hit what? W, that was a W, and then I hit X. So Y and X are going to be the ones on the end. It doesn't matter which one I pick. I could pick Z, I could pick W, it doesn't matter. Okay? So I could call it YZX, okay, arc YZX, or I could call it what? YWX. Isn't that the same exact arc? Or I could go backwards, couldn't I? I could start at X and go XWY. Don't put 4 of them in there. Don't go YZWX. All right, just use 3. If it's a semicircle or if it's a major arc, we got to use 3 points. If it's a minor arc, we just use the 2, right? Because from W to X, I'm going the shortest distance, right? And some people might look at it and say, well, you could go from W all the way around here to X, but is that the arc that I'm talking about? No, I want that little minor arc, WX, so I only put 2 letters. All right? So it's important to know how to label these things. So we're on the same page, we're talking the same language, and all that good stuff. Make sense? All right. Let's actually find a couple things. Do I do that in my notes? I'm checking my notes. I don't really do it, but let's do it now. This is getting to be a little messy, but we'll write some more things in there. What if I ask you to find arc yx equals question mark? Yzx? I guess you could do that. I think there's a really easy way to do it. What's the easiest way to do it? Exactly. The 180 minus 60. See this? Because if I'm trying to find arc yx, which is this one right here, I need to find that angle, right? So you could go to the angles or you could go to the arcs. But look at it. From here to here is 180, isn't it? This is 60. So what's this angle right here then? That's 120. So what's the arc going to be? So arc yx is also what? 120. Okay? See what they're going to do here? All right, they're going to ask you to find missing angles, missing arcs, and all that good stuff. All right, so you just got to know how they relate to each other. This is still a central angle, isn't it? You got a bunch of central angles here, don't you? You got this as 120, you got this as 60, you got this as 180. All right, so there's not just like one specific central angle. Any angle that has its vertex at the center is considered to be a central angle. All right. They could ask you a bunch of things. They could ask you, I don't know, what arc WYX is. Let's do that. WYX. There's W, there's Y, there's X. So it's all of this. So it's everything except what? The 60. So really, what's the easiest way to do that? 360 minus 60, which is obviously 300 degrees. I didn't mark the arc on there, but if I did, it would go from here all the way around to here, right? This is what's left over. Pretty simple. All right, enough of that. I got a thing called the angle addition postulate. It's kind of self-explanatory. So if I wanted to, or arc addition postulate, if I wanted to add arc WX and add it to arc YX, what do you think you would do? Well, what is WX? It's 60, okay? 60 degrees. What's YX or XY? It's 120. So if I add them together, what do I get? I get 180. You get it? So you can add arcs together as well. Yeah, that's kind of self-explanatory. You probably could have figured that out on your own. All right, let's move on. Let's do an example. There's my circle. And let's put some stuff in here. It's going to kind of look a little bit like what we just did. That goes like this. This goes like this. And this kind of goes like that. Almost looks like a Trivial Pursuit pie. You guys even know what Trivial Pursuit is? You probably don't even know what that is, do you? It was a board game. It was super famous, I don't know, back in the 90s maybe. They got all these cards with these trivia questions on it. Nobody ever heard of it? All right. Well, it used to be new because it's not anymore. All right, so this is an example. What they're going to give you is, let's just give it another color. This is 60 degrees. Probably looks a little more than 60, but that's okay. We'll just go by what they tell us. And this is W, X, Y, and Z. All right, and they ask you to find a bunch of stuff. Here's what they ask you to find. Okay, so part A, find arc ZWY. Part B, YXW, YXW. Then part C, they ask you to find ZW, arc ZW. And last one, part D, they ask you to find ZX, arc ZX. Okay, and this is the information they give you. That's all they give you. WY is a diameter, okay? Everybody see that? So that is a diameter. And let's figure it out. ZWY, where is that? ZWY. Everybody looking? So it goes all the way around until it hits here. Remember, that's a major arc, right? It's either a semicircle or a major arc, but it's definitely a major arc. It comes to here. So what's the best way to solve for that big old arc right there? You got it. Take the whole entire circle, take 45 away from it, and so your work is 360 minus 45. What's that, 315? Yep, 315 degrees. So that's not too bad, is it? I mean, the math is really no more difficult than we've ever done. All right, it's just knowing what to do, what to add, what to subtract, and all that. And what these things mean, all right? What do they represent? So here we go, Y, X, W. Where's that? There's Y, there's X, there's W. Oh, that's an easy one. What's arc Y, X, W? This arc from here all the way to here. It's 180 because it goes from one end of the diameter to the other end of the diameter. So that's got to be 180 degrees. Questions on that? Okay. Arc ZW. Since it's only 2 letters, what kind of an arc should it be? A minor arc, right? So it's got to be less than 180 degrees. So ZW, where's that? ZW, that goes from here to here. Yeah, ZW, that's right. From here to here is 180. If this is 45, sometimes I like looking at the central angles more than I like looking at the arcs because they're kind of closer to each other. Do you see that? All right, that's kind of what I like to do. So watch, I want to find ZW. So I want to find this angle. If I find that angle, that arc's going to be the same exact thing. All right, so I go 180 minus 45. You see that? Because this is a straight line right there. If I want to find this little bit right there, I take 45 away from 180. So 180 minus 45, is that 135? 135. So if this angle is 135, then this arc is 135. That's what they want you to see. All right, one more, ZX. Where's ZX? How do you know which way? Because it's not this way, because that would be more than 180 degrees. Right? This is a minor arc. So you can't go this way because that's going to be more than 180. So you have to go which way? This way right here. Okay? Make sense? So let's do this. Do I know that angle right there? What is that? Is it? This angle right here? It's 120, right? Because look, there's my straight line, right? This is 60. That angle right there has got to be 120. And what am I trying to find? ZX. So I'm trying to go from here all the way to here. So this is what I'm trying to find. So once you know that's 120, now the rest of it's kind of easy. 45 plus 120. All right? 45 plus 120. And that is 165. And it's in degrees. Make sure you put the degrees symbol. So that's the kind of stuff they're going to ask you to do. That's not so bad, right? As long as you know that the angle is equal to the arc, right? The central angle is equal to the arc that it cuts off. That's kind of how they say it. Does that look reasonable? Yeah, it's not too bad. All right, let's move on. What else we got? Oh, now we just talked about the measure of the arc, which means how many degrees it is, all right? This time, we're going to talk about the length, how long the arc is. Okay, so the arc goes like this. If I was to measure it, if I had maybe like a tape measure that was bendy, right, and I could bend it around the arc and measure it, that's what I'm trying to find. So we already know how to find the distance or the length that goes all the way around the circle. What would I call that? What if I started here and I wanted to go all the way around the circle and I want to find out how long that is? Let's put a radius in here. Okay? So how would I find that? What if I knew the radius? I don't know, give me a number for a radius. Give me just an easy number. 5? Okay, so let's say the radius is 5. And I want to find the distance, the length, all the way around that whole circle. It's something we have talked about that this year. What word am I using? Pi? Circumference, correct. Pi is being used, but pi is not the distance around a whole circle. Circumference. What is the circumference? It's the distance. It's the length that goes around the whole entire circle. With me? A lot of people's heads down and writing. Are you taking notes or are you writing something else? I don't know. Maybe you're writing notes. That'd be good. Do you remember the formula for circumference in terms of pi? Not in terms of pi. In terms of the radius. 2 pi, what? Times the radius. 2 pi r. Everybody got that? So what if, and we could put the number, I don't even care about putting the numbers in for the 5, all right? Let's just say that. So this is the distance around the whole entire circle, around 360 degrees, correct? What if I asked you to find the circumference, I'll put just a C, of 180 degrees? That's it. So watch. But where do you get that 2 from? Because 180 over what? How do I get that half? I go 180 over 360 because that's what I'm finding now. I'm not finding the full circle. I'm not finding all 360 degrees. I'm finding how much? Just 180. 180 out of what? 360, the whole circle. That's going to give you a half, isn't it? So what would the circumference be of half a circle? It would just be 180 over 360, what? 2 pi r. That's right. 2 pi r. Question. What does what say? I don't know what you're pointing at. This? Circumference of 180 degrees. That's 180 degrees. That's what that says. And that's C for circumference. So it's just the way I wrote it. It's not like an official way to write it, but I don't know. I thought it might be easy to see. Watch. If I did this, if I extended it here, the circumference of the whole circle is just 2 pi r. But I just want to go around from here to here, half the circle, or how many degrees? 180 degrees. So I want to find the circumference of just going around what? 180 degrees. That's why I put that. Does that make sense? Again, it's not like an official way to write it or anything. It's just easy way to write it. Yeah, because I'm not finding the whole circumference. I'm not finding 360 degrees out of 360 degrees, am I? I'm only finding what? 180 out of 360. So let's go beyond that. Let's say I was going to go to here. And let's say this is 60 degrees. Let's forget the radius. I'm not actually putting numbers in right now. We can do that later when we get to the example. All right. What if I just wanted to find the distance from there to there? Around, okay, it's got to go around the circle like this. Okay, so it's kind of curved. So it's not just going to be a straight line. It's curved. But how do I find the distance from here to here? Everybody see that? So it was a whole circle. I went 360 over 360, 2 pi r, correct? If it was half a circle, I do what? 180 over 360, 2 pi r. So what if I find the distance of an arc? Now, again, this is not official way to write this, but I don't know. It just kind of popped in my head. The circumference of only how much? 60 degrees. Does that make sense to you? All right. I don't think I've ever written that way before, but it just thought of it. So if I'm just going to go 60 degrees out of the whole entire circle, what am I going to do? 60 over 360. And what is that? What is 60 over 360? It's what? It's 1/6. So this is how much? 1/6 of the whole circle. 180 over 360 is how much? 1/2 of the whole circle. Does it make sense? All right, so this would be 60 over 360, what? 2 pi r. And you put all those numbers. Whatever the radius is, you'd put it in for this, and you could get the distance from here to here. What if I did some weird angle, and I didn't know it was half, I didn't know it was a quarter, I didn't know it was 1/6. What if it was a weird number angle, like 27.3 degrees, all right? And I asked you to find the length of that arc. Okay, what if I asked you to find the length of that arc? It's not a straight line, even though I kind of drew it kind of straight-ish, but that's a curve, right? So how in the world would I do that? How would I find the circumference, okay, or the distance, or the length of? What they're going to say, they're not going to use this. They're going to say the length. We'll just call it AB. Make it simple. What if I ask you to find the length of arc AB? That's what they're going to ask you to do. Okay? So there's AB, all right? The angle is the same as this angle, right? So this arc is 27.3 degrees. But is that the length of the arc? Is 27.3 degrees the length of it? No, it's the measure of the arc, okay? So how do I find the actual length? If I actually took a ruler, right? Well, not a straight ruler because I couldn't bend it. But if I had a bendy ruler, okay, and I was able to bend it around that arc right there, what would the length of that be? What would I do? You got it. 27, kind of looks like it. 27.3 degrees, what? Out of 360, and then what? 2 pi r. Okay? And then whatever that is. I don't know what that is. I just made that up off the top of my head. But you can put that into a calculator, all right? Get a number, depending what r is. It all depends what the radius is as well. That's the only thing I needed to know, isn't it? Was the radius and that angle, I guess. And there you go. Well, they'll tell you the radius. Okay? What if I made the radius 9 and make that C? And what if I asked you, tell you what, we'll forget about that 27.3 right now. This is the example in the book that they give you. Find the length of AC, arc AC. So I put arc AC. There's no special symbol for the length of it, so I just write the word length of arc AC. All right? So here's your problem. Here it is right in front of you. What would you do? Well, we already know AC. That's this one right here. So that's 60 degrees. If that's 60 degrees, this is 60 degrees. But I want to find the actual length of it. All right? So it's 60 over 360, 2 pi what? 9. Okay? And you just work that thing out. You could do a little bit of this in your head. Watch. If you just want to keep it in terms of pi, and actually if it comes out kind of nice and even, we can do that. So let's simplify this. So that and that cancel. Agreed? This 6 goes into this. How many times? 6 times. Let's see. What else cancels? This 2 goes with this 6. What? 3 times. Now you got a 9 on the top and a 3 on the bottom. What is that? That's a 3. Don't forget, what else do you have? A pi. So you could just keep it like that if you wanted to. Or you could chuck it into a calculator and get whatever you get. Remember, when we do these things, don't use the pi button on the calculator. That's an ugly pi. All right, use what? 3.14. All right, so don't use the whole pi button on your calculator. Just put in 3.14. That way we're all consistent. We're all getting the same answers, okay? And you could put that in here and get whatever that is. But 3 pi, that's a nice looking answer, isn't it? Just leaving it like that. You can do all that work without a calculator? Sure. All right, let's do a little bit more. Yeah, I think that's good. I was going to do something else. Oh, these are just examples. Let's see what else I have to do. Tell you what, I am not going to do example 2. I think that was enough, what we just did right there. Oh, okay. Yeah, I think you're right. You are right. 2A, I don't think we have to do, but let's do 2B. You are right on that. So let's definitely do that. I kind of missed that. So let's do example 2B. Example. And they give you a little circle. I'll just make it a big circle, just like that. And they give you this. They give you that. And they don't tell you the angle this time. This is where it's a little bit trickier. This time they don't tell you the angle. Remember what letter we used? It's in the Greek alphabet. Call it theta. Remember that? So I'm going to call it theta. It's an unknown angle. They tell you the radius, okay, which is 15. And they also tell you the arc. And they write it in terms of pi. Just like we wrote that other answer, 3 pi for the length. They write this as 3 pi. Don't let that fool you. It actually makes it a little bit easier. Okay, when they give it to you in terms of pi, it actually makes it kind of easy. Let's come. I was debating a second ago. You heard me pause a little bit on whether I should tell you this, but I am going to. Do you see how it's always 180 over 360, 60 over 360? The other one was what? 27.3 over 360. So these are all angles, right? If we don't know it, what is the length of an arc? It's equal to what? Theta over 360, and then what? 2 pi r. So that's your official formula. Does that make sense? So now that's going to help us out a little bit with this. So let's write that down. So what's our formula for the length? The length, I'll just put length equals theta over what? 360 2 pi r. Okay? So now what we're going to do is take all the stuff we know, we're going to stick it into this formula, and then try to solve for theta. Theta is just a letter, okay? Don't get worried about it, all right? It's just, I could have put an X there. Wouldn't make any difference. It'd be the same kind of thing, all right? So what is the length of this arc? What they tell you the length of the arc. What is the length of the arc? 5 pi. So let's put a 5 pi right there. Equals theta. Do I know theta? No, so I keep it, what? Theta over 360 times what? 2 times pi times r. What's the r? It's 15, so I'll put in the r. And what do we have to do? What do we have to solve for? Solve for theta, that's right. Okay, so let's do that. First of all, I'm going to try to make this as easy as I can. I got a pi on this side, a pi on this side. So what can I do with that? Just divide them both sides by pi. They just cancel each other out. Everybody see that? All right. What's another thing? I got 2 times 15. What's 2 times 15? It's 30. So I'm going to put the 30 right there. Is that all right? Just to make it a little bit easier on us. Again, we're trying to solve for theta. I see something. That 0 and that 0 cancel out. Right? This 3 goes into 36. 3 goes into 36 how many times? 12 times. All right, it's a little messy. Let's clean it up a little bit. So what do I have on the left-hand side? Just a 5. What do I have on the right-hand side? I mean, almost everything canceled out except for what? Theta over 12. Yeah. And it came out to 12, 1 over 12. Okay? Everybody see that? Now, how do I get rid of that 12? It's being divided. How do I get rid of something that's being divided? I multiply it. So I multiply this side by 12 and multiply this side by 12. And what's theta? It's 60 degrees. There it is. And that's what that answer is right there. Just 60 degrees. Does that make sense? Yeah. Now, when they don't give you in terms of pi, it may not be so easy. That might be confusing for you, but if you look at it step by step, go back and watch the video, pause it after every step, make sure you understand what I just did. It actually works out kind of a lot easier, right, when they do that. And plus the 30 and the 360 divided evenly. It's not always going to do that. Sometimes you might need a calculator to do that kind of stuff. All right. Well, we didn't quite finish, and we got quite a bit to do. So I am going to stop there. My plan was to teach the whole lesson today, but we just didn't have time to do that. So I didn't write down the homework here. Let's look at the lesson plan. It says 2 to 16, but you may not be able to do them all, but try to do as many as you can. All right. So it says 2 to 16, and this would be section, 8.3? Yep. Section 8.3. You should be able to do quite a few of these. All right. Do you remember doing, you remember doing this? That shaded in stuff? You remember that? Okay. The sector and the segment. That's what we're going to do tomorrow. Okay. We're going to talk about sector and segment. So when you see these problems with a sector and a segment, don't do those. I don't know what they are. I don't have it right in front of me. But don't do those. But just look at them and do the ones that we covered today. We'll finish it up tomorrow. So we won't be doing 8.4 tomorrow like it says on the lesson plan. Everybody good?